We return to our push-button sensor once more to learn a function frequently used in the KNX system, the dimming function, more precisely, dimming relative. It is defined as follows. The push button tells the dimming actuator to dim up or down relative to its current dim value. This happens when the push button is pressed long, using its communication object for dimming. In this picture, it is the rocker top which sends the command dimming brighter and rocker bottom sending dimming darker. The push button, however, has three objects. So there is another one for switching, which is used with short button operations. Rocker top equals on, rocker bottom equals off. And the third one is a status object, which receives the message sent by the actuator to operate the status LED corresponding to the current lighting status. This graphic shows on the timeline what happens when you operate the dimming rocker. It is the user function dimming by start-stop telegrams, from left to right. The actuator is turned off. Now you press the rocker top long and keep it pressed for the time being. The first telegram is the command start dimming brighter. The actuator will switch on and starts dimming up from 0. As soon as we notice the required brightness to be reached, we release the rocker. Another telegram is sent to the bus, the stop telegram. As soon as the actuator receives it, it will terminate dimming. A dim value of approximately 50% is now reached. The third telegram is a switch-off command sent after a short operation of the rocker bottom. Now, a little later, the light shall be turned on again by telegram 4, short operation of rocker top. But what will be the result? To what dimming value will the actuator go? With KNX dimmers, you can usually determine to what value the actuator will go when switched on, be it fully on or 100%, another fixed value, or the last value before the last switch-off action. The latter one is exactly what happens here. The dimmer jumps back up to the last value of 50%. If this isn't what you want, then you must operate the rocker like described before, in this example by holding the button pressed, to dim darker by telegram 5 and stop by telegram 6. The function dimming by start-stop is not the only one. This graphic shows that dimming is also possible by cyclically sent telegrams. But this method is significantly different from the start-stop method. So why have both methods been invented? Agreed, the cyclical dimming has some disadvantages. There are almost each time more telegrams than with start-stop. And you can obtain only certain values, like the lines in a grid. Here the step size is 12.5%. By start-stop you can reach every intermediate dim value. But this method also has an advantage. Missing telegrams, for example, caused by interference or bus telegram overload, only result in a little longer dimming time. But if you use start-stop dimming, then a missing telegram either leads to no function at all, if it is the first one, or makes the dimmer go up or down to the limit. This can occur with wireless data transmission. Therefore, wireless remote controls and also constant light controllers prefer this method of dimming. Also with dimming, we want to look at the actuator's side. From left to right, the BCU receives a dim telegram. It calculates the digital control value, usually an 8-bit value, and sends it to the application module via the PEI. What you see in the graphic is a shift register interface. The single bits of the binary control value are transferred to the receiver shift register of the application module. After termination of this step, the DAC of the application module converts it to an analog control value. These analog interfaces for lighting ballasts, still very popular in some regions of the world, operate between 1 and 10 volt DC. Value control, however, is not the only function required here, to switch and dim the lamp to the demanded value. In the upper part of the application module, you can see a relay. It also receives a switching command to provide operation voltage for the ballast and the lamp, if not already switched on. Therefore, this type of device is called switch dim actuator. Of course, there are also other types of dimmers, such which don't need a relay and which control the lamp without a ballast. You might have heard of leading and trailing edge dimmers. If a dimmer can do both, it is called a universal dimmer. If it additionally can operate the today common LED lamps, it is an LED dimmer. An LED dimmer also uses either the trailing or the leading edge method, but avoids the capacitive residual current in the off mode, which could cause low power LEDs to continue lighting or even flickering. All dimming actuators, however, have one in common: certain configuration parameters for the behavior when being controlled by dim commands. This could be, for example, the additional requirement of a dimming telegram to switch the lamp on or off. But we will focus on that in the practical lessons. Here we have the concrete sample of the switching dimming actuator N526E02 as it is integrated to the Gamma Training Kit 5. On the right side you see the block diagram of the actuator, how it is wired to the dynamic ballast for 1 to 10 volt control. Why is it not a control voltage of 0 to 10 volt? This is the explanation. A switching dimming actuator always must turn on the operation voltage for the electronic control gear ECG, in most cases to 30 volt AC. This happens by means of a floating contact relay. This relay doesn't use a supply voltage required also by the actuator, but exactly the voltage required by the ballast, which then of course can differ from the commonly used 230 volts in Europe. So one is more flexible. The actuator can also be used in countries which use, for example, 120 volt AC line voltage. The control voltage range, starting from 1 volt DC instead of 0, results from early developments using the ECG to supply the control circuit on the switch dim actuator. There must be a safe galvanic separation between the bus controller and the application module because the KNX bus is safety extra low voltage SELV. The operation energy had to be supplied by the ballast. The application circuit, however, could only work at or above 1 volt DC. So this was the minimum dimming level as well. Nowadays, this is no restriction anymore because the bus couplers can transfer the operation energy by means of switching power supplies. But the standard for the 1 to 10 volt electronic ballasts still exists and needs to be heeded. So whenever you want to use analog electronic control gear in the future, make sure they are of the type 1 to 10 volt, which provide an active output for the control voltage. Let's turn to the next frequent user function, the solar protection control. The wording solar protection is used more and more for all control gear which actually shall protect against excessive solar radiation, Venetian blinds, awnings, roller blinds or curtains. When we take the classic Venetian blind mounted on the outside of the window, we have to distinguish, similar to dimming control, between two functions. For one, the move command. It is often called blinds up-down in the application programs, but also wordings like move operation, movement object, long time operation, and solar protection up-down are used for the same function. This command will be generated by a long button operation. On the other hand, a command to stop the running motor is required. This function is called, among others, step operation, step stop object, short time operation, and stop slats open closed. It will be triggered, of course, by a short button operation. Why does it make little sense to define it vice versa? Well, this should be obvious to everyone. Just imagine the blind starts moving on a short button press. This might still be okay, but to stop it by a long button operation means you always have to wait for at least 1 second until it actually stops. This makes no sense at all. But by mistake this happens quite often, because the system integrator doesn't pay attention when assigning the group addresses to the objects. In contrary to the dimming function, which has two different value formats, 1-bit and 4-bit, the blind operations are both 1-bit. We will come back to that issue in the practical lessons. Another issue is the LED on the rocker. Can it still be used as a status indication for the actuator? In contrary to a dimmer, there can't be a single binary feedback. It makes sense to send end position feedbacks, being in the upper or lower end position, or analog position reports for the height and the slats, which mean two 8-bit values. Neither one can be shown by a single binary indication. Therefore, the object status LED is crossed out here. How does the user function blinds operation work on the timeline? When the button is pressed, a timer is started. If it doesn't expire until the button is released, T1, the step telegram is sent. The reaction to this telegram depends on the state of the actuator in that moment. If the up or down contact is closed, that means the motor is spinning, it will be opened and the motor stops. If the motor doesn't run, because neither contact is closed, there will be a short step movement. If you hold the button pressed for longer than T1, the telegram for move up or down will be sent immediately after expiry of T2, which is the parameterized timer for distinction between short and long operation. Other than with the dimmer operation, now the button must be released. You press it once more short when the desired position of the blind is reached. Useful hint for the control of other motorized equipment, such as windows, awnings or roller blinds. You must settle the type in the actuator correctly. Default is always Venetian blinds. If you don't change it for roller blinds, then each time you press the button short, they will also move for a short time, which however often annoys the user. Only if the parameter is set to type of shading roller blinds, there won't be movement when sending step-stop telegrams. For the sun protection actuator, here is also a very simple block circuit diagram. You see that there are two contacts in series. While S2 is the changeover relay, S1 interrupts the power. Motor drives have an inductive phase shift. Single-phase motors also need a phase shift capacitor to control the spinning sense. Both technical details together cause an electric arc over the opening contacts when the motor is stopped. When you reverse the spinning sense too quickly, the impact of this arc is boosted and the contacts wear off too fast. Therefore, the relay S1 is also subject to a reverse pause timer, normally 1 second or higher. This reliably avoids excessive contact burn-off. This slide shows the basic three objects of a sun protection or Venetian blind actuator and how they are used. All modern sun protection actuators have a lot more objects, but this would confuse us here only, as we only want to understand the principle of the state machine of such an actuator. Motor control is a little more complicated than lighting, because it is very often required to have a certain priority control. Let's start with the simple push-button operation. It uses the objects blinds up-down and slats or louvers open-close. We have already learned how we have to operate the buttons for these functions. Long equals up-down, short means louvers control. The actuator is connected to the manual push button through the group addresses 2112 and 2113. This connection, however, is only active when a bus telegram is sent. A superimposed function is automatic 2131. Here we see the first time that actuator objects can be assigned to more than just one group address. Automatic could be sent by a sunlight sensor. If the sun shines bright enough, the blinds can be closed to avoid overheating of the building. A formally sent open command will be extinguished by this, as it is always the last command which is valid and will be executed. The third object is the safety object. It is linked to a wind sensor via address 2199. If the wind sensor sends an alarm for strong wind, which is value of 1, two things happen. The blinds are moved up into a safe position to avoid destruction by the strong winds. Manual control will be locked. Such kind of control is called gate function. Both gates for manual operation will be locked by the 1 in the alarm telegram. That means neither manual control nor automatic control will work. The wind alarm has priority. When the alarm ends, the wind sensor sends a logic 0, which opens the gates once more. But the blind remains in the safety position. Why? The solution is, as one doesn't know at which time of the day the alarm situation terminates, it is best only to unlock the manual control instead of repositioning the blinds by active commands. So the user can decide on his own what to do. The automatic control could be configured to send its telegram cyclically in short intervals, so after a short delay the blinds would be properly positioned again. Finally, I want to remark that modern sun protection actuators have many more communication objects. Why and what for you will learn when you come back to our advanced KNX course. Our practical sample from the Gamma Training Kit 5. We have two actuators for parapet and automation box integrated. On the user side, they have the usual changeover relays and the interrupter relay for each channel. What you, however, can't see on this block circuit scheme copied from the technical product info. But the relays exist like described before. As additional feature, this actuator also has an end position recognition. It uses the properties of the tube motors, which have two mechanical contact interrupters for a forced switch off when reaching the end position, plus a phase shift capacitor, which is required to determine the spinning direction. As long as the motor is spinning between the end position switches, both are closed. The operation voltage is high ohmic loop through the phase shift capacitor to the other direction terminal. It can be detected by the electronics of the actuator by means of a shunt. As soon as such a contact opens forcedly, the loopback voltage is also interrupted. The detection circuit of the actuator also will switch off the relay. Moreover, the true tafel time is being measured through this, so the integrator doesn't have to care about precise spinning timers parameterization. More details about this also in the advanced KNX training.